Okay, so to subtract radicals, we need both the index and the radicand to match. And since they do, we just do the coefficients. -5 minus 3 is -8. Keep the radicand the same. So again, to subtract, we need the radicand to match, which it does, and the index to match. So here we can put in a -1 for the coefficient. So -4 minus 1 is -5. Here we would want to simplify the radicals before doing anything else. Radical 27 can be rewritten as 9 times 3, and square root of 9 is 3. So we can rewrite all of these. Well, let me go back to this step. Let me just do this part first. Okay, so now 9 is equal to 3 squared, so square root of 9 is 3, so I can take the 3 out. So -3 times 3 is -9, and I still have the radical 3 left over. Same thing here. Take the 3 outside. Take this 3 outside also. Okay, so sorry, there was already a -3 there, so when I take a new 3 out, -3 times 3 is -9. And then now all of them have matching radicands and matching indices. So -9 minus 9 is -18, minus another 9 is -27. Okay, so let's simplify the radicals first. So radical 45 can be rewritten as 3 squared times 5. Radical 20 can be rewritten as 2 squared times 5. And radical 6 we can't really split up into anything useful. So we take this 3 out to join the -2. -2 times 3 is -6. Keep the square root of 5 that's left over. Here we take the 2 outside. -3 times 2 is again -6. And again, we keep the radical 5. And this last term, we couldn't do anything. Okay, so these first two terms are exactly alike. They're both radical 5 with an index of 2. So -6 minus 6 is -12. And then we keep that last term. Okay, so let's simplify the radicals first. We're doing cube roots, so I'm looking for things cubed. So this first term, I can split up -3 into -1 cubed, which is also -1 times +3. This middle term, so 162 can be split up into 27 times 6, and 27 is 3 cubed. And this last term, 81 can be split up into 27 times 3, and 27 is again 3 cubed. Okay, so now we take things outside. -1 times -3 is +3. +3 times 2 is +6. And +3 times 3 is +9. Okay, so now we look for exactly like terms to combine by addition, and the first and the last terms. So we do 3 plus 9 is 12, and then plus this middle term. Okay, so let's simplify the radicals first. Negative cube root of, and then we're going to split up 320 into 64 times 5. Radical 5, or cube root of 5, we can't really split up. 135 will split up into 27 times 5. And 16 will split into 8 times 2. Okay, so let's rewrite some of these bigger numbers as with exponents. So 64 is equal to 4 cubed. 27 is equal to 3 cubed. And 8 is equal to 2 cubed. So now I can take things to the outside. So this 4 goes to the outside, so now -4 cube root of the 5 that's left over. Okay, over here, take this 3 outside. So 3 times 2 is 6. And here, take the 2 outside. So 2 times 2 is 4. Okay, so let's see what can combine. These first 3 terms all have cube root of 5 as their radical portion, so we combine all their coefficients. -4 minus another 4 is now -8, plus +6 is now -2. And then this last term doesn't combine with the others because its radicand is different. Okay, cube root of 3, we can't simplify the 3 at all, but this -20 can be rewritten as -1 cubed times +20. And then we take that negative outside. Okay, so to make it a little clearer, I'll put -1 on the outside. Okay, so to multiply these, they do have the same index, so we can combine them. So coefficients, 1 times -1 is -1, and then multiply the radicands, 3 times 20 is 60. And we don't really need the 1 in front. Okay, so radical 6 times radical 2, we can multiply because they both have invisible index of 2. So that becomes, you just keep the same index, and 6 times 2 is 12. But 12 can be rewritten as 4 times 3, and 4 is 2 squared. So we take the 2 outside, so 2 radical 3. Okay, so for 9, we need to distribute because this is 2 separate terms inside. So we multiply the outsides, 3 times 4 is 12, keep the radical. And then over here, multiply the outsides again, 3 times -3 is -9, radical 3 times radical 5 is radical 15. Okay, so for problem 10, we have invisible 1 here, so 4 times 1 is 4, radical 15 times radical 6 is radical 90. And then we distribute again over here, 4 times another invisible 1 is still 4, radical 15 times radical 5 is radical 75. Okay, so I can rewrite these radicals. I can rewrite 90 as 9 times 10, and 9 is 3 squared. And then 75 I can rewrite as 25 times 3, and 25 is 5 squared. Okay, so I take this 3 outside to join the 4, so now it's 12 radical 10. And I take this 5 outside to join the 4, 5 times 4 is 20. Okay, so the answer to problem 10 is 12 radical 10 plus 20 radical 3. Okay, so we need to distribute. So invisible 1 in front, 1 times 2 is 2, then the radical 15 times 10 is 150. And then again, 1 times -4 is -4, 15 times radical 6 is radical 90. Okay, so 150 can be rewritten as 25 times 6, and 25 is 5 squared. 90 can be rewritten as 9 times 10, and 9 is 3 squared. So here I take the 5 outside to join the 2, 5 times 2 is 10. And here I take the 3 outside, 3 times -4 is -12. Okay, so for 12 I need to distribute. So radical 2a times 7 radical 2a. So invisible 1 in front, 1 times 7 is 7. Then 2a times 2a is 4a squared. So next, radical 2a times -5. So 1 times -5 is -5. Then I attach the radical. Next, -5 times 7 radical 2a. -5 times 7 is -35. And then I attach the radical again. And then -5 times -5 is +25. Okay, so 4a squared, So 4 I can rewrite as 2 squared. So then I take the 2 outside. 2 times 7 is 14. And then I take the a outside. So there's nothing left in the radical. So these middle two terms can combine because they're both square root of 2a. Negative 5 minus 35 is now negative 40 of those. And then I have the plus 25 at the end. So here we need to distribute. So radical 3 times radical 3 is radical 9. Radical 3 times negative 5, radical 5x. So multiply the coefficients first. 1 times negative 5 is negative 5. Radical 3 times radical 5x is 15x. Okay, so then radical 5x times radical 3 is 15x, radical 15x. And then radical 5x times negative 5, radical 5x. Multiply the coefficients first. 1 times negative 5 is negative 5. Radical 5x times radical 5x is radical 25x squared. Okay, so some of these can simplify. Square root of 9 is 3. Okay, so I can rewrite this 25 as 5 squared. And then in the middle here, these are exactly like terms. They're both square root of 15x. So I have negative 5 plus 1. So that's minus 4 radical 15x. And then over here, I can take the 5 outside. So negative 5 times 5 is negative 25. And then I can take an x outside also. So there's nothing left over in the radical, actually. So bring the 3 down, bring the minus 4 radical 15x down, and that is the fully simplified answer. Okay, radical 9 over radical 25. So here both numbers are perfect squares. You just do them separately. Square root of 9 is 3, square root of 25 is 5. Okay, 15. So let's try to, we can't reduce by 3. Well, we can, but let's go ahead and just rewrite it. So I'll leave the numerator alone, but the denominator I can split up into 2 squared, which is 4 times 3. So I'm looking to make this 3 squared to match the invisible index of 2. So the 2's are already matching, the 3's aren't. So I need to multiply top and bottom by an extra radical 3. So in the numerator, radical 15 times radical 3 is radical 45 now. And in the denominator, I've got 2 squared from the beginning, and then now 3 times 3 means I also have a 3 squared. Okay, so both the 2 and the 3 come outside. And the numerator, I can rewrite. Radical 45 is equal to radical 9 times 5. And 9 is 3 squared. Okay, so I'll take the 3 outside. So I get 3 radical 5 over 2 times 3 is 6. Okay, so sorry, back over here, I rewrote 45 as 9. 3 squared is 9 times 5. Then I took the 3 outside to get to here. So now I can reduce the outside numbers. 3 and 6 are both divisible by 3. 3 divided by 3 is 1. 6 divided by 3 is 2. So radical 5 over 2 would be the final answer. Okay, 16, we have a radical 5 in the denominator. So this 5 is currently to the first power, but the index is 2. So we need to multiply by an extra radical 5 in both top and bottom. So in the numerator, radical 5 times radical 4 is radical 20. In the denominator, 4 times invisible 1 is still 4. Then in the radical, 5 times 5 is 5 squared. So again, now we have what we want. The exponent matches the index, so we take the 5 outside. So radical 20 over 4 times 5. Okay, but I can rewrite radical 20 as radical 2 squared, which is 4 times 5. Okay, so I take the 2 outside to get 2 radical 5 over 20. And then I can reduce the 2 and the 20 on the outsides, both divisible by 2. 2 divided by 2 is 1. 20 divided by 2 is 10. So radical 5 over 10. Okay, 17. We have a radical 17 in the denominator we want to get rid of. So since it's a square root, we need to make this 17 a 17 squared. So we need to multiply by an extra radical 17. Okay, so in the numerator, we need to distribute because these are two separate terms separated by a minus sign. So first, negative 3 times radical 17 is negative 3 radical 17. And then radical 17 times negative radical 2 is minus radical 34. And in the denominator, okay, 3 times invisible 1 is still 3. And then 17 times 17 is now 17 squared. Okay, so we have our goal, the exponent and index match, so we take the 17 outside. And 3 times 17 is 51. Okay, so 22. We have a fifth root in the denominator, so we need to make it something to the fifth power. Okay, so this is not the only way to do this, but maybe the simplest to understand. So I want to switch this negative 4 that's currently to the first power to negative 4 all to the fifth power. So I'm missing 4 extra groups of negative 4. Okay, so in the denominator, I still have this 4 on the outside, and I still have the fifth root, but now I have 1 group over here and 4 more over here. Now I have 5 groups of negative 4. Okay, then in my numerator, I have, let me rewrite this 5 to the 12th. No, actually, I'll leave it for now. Okay, so we multiply the inside, so 12 times negative 4 to the fourth power. Well, negative 4 to the fourth power is 256. So that's kind of a large number to work with. So maybe there's a different way we could have done this. So why don't we look back at this 12? Well, we can rewrite 12 as negative 3 times negative 4. So let me redo the numerator. Okay, so I've got this extra negative 3 in front. But then now I have a negative 4 and 4 more negative 4s. So now I have negative 4 to the fifth power in my numerator. Okay, so the reason I do this is so that I can take it outside because it matches the fifth root. Okay, so I take the negative 4 out, and I get fifth root of negative 3. And in the denominator, I also take this out. So 4 times negative 4 is negative 16. And then I can reduce my outside numbers. Negative 4 and negative 16 can both be divided by negative 4. So negative 4 divided by negative 4 is 1, and negative 16 divided by negative 4 is positive 4. Okay, and then the last thing we can do is we have a negative inside an odd root. So I can rewrite this as negative 1 to the 5th power times positive 3. So the reason I do that is so that I can take the negative 1 outside. So negative 5th root of positive 3 all over 4. Okay, so 23. Well, 162 I'm going to want to find the prime factorization of. So 162 is equal to 81 times 2. And 81 is 3 to the 4th power. So 2 times 81, which is 2 times 3 to the 4th power. So this time, neither the 2 nor the 3 has the correct exponent currently. So I need both the 2 and the 3 to become to the 5th power. Okay, so I need to figure out how much each part is missing. The 2 is currently to the 1st power. In order to get it to the 5th power, I need 4 more. Okay, on the other hand, the 3 is already to the 4th power. To get to the 5th power, I only need 1 extra 3. Okay, so let's combine these. I'll do this on scratch paper. Okay, so first I'll focus on the numerator. So I've got a 2 here and 2 to the 4th here, so now I'm at 2 to the 5th, and I have an extra times 3 at the end. So next to the denominator, I have this 3 on the outside from the beginning of the problem. Okay, 2 to the 1st times 2 to the 4th is now 2 to the 5th, and 3 to the 4th times 3 to the 1st is now 3 to the 5th. Okay, so let's take everything outside that we can. So this 2 will move outside. The 3 needs to stay inside in the numerator. And here the 2 moves outside. 3 times 2 is 6, but then the 3 moves outside also. So 3 times 2 is 6, times 3 is 18. Okay, and then the 2 and the 18 can be reduced by dividing by 2. So we get the 5th root of the 5th root of 3 all over 9. Okay, moving on, 24. So 4th root of 5 over 4 times the 4th root of 27. Well, let's rewrite 27 with exponents. So 27 is equal to 3 cubed. Okay, so we're trying to get to the 4th power. 3 cubed is almost there. We just need a single extra 3. Okay, so in the numerator, we multiply the radicands. 5 times 3 is 15. In the denominator, we have the 4 on the outside. Then we still have the 4th root. 3 cubed times 3 to the 1st is now 3 to the 4th. And since these match, we get to take the 3 outside. So that becomes 4th root of 15 over 4 times 3 is 12. Okay, 25. We have the 4th root of 6. So in order to get rid of the 4th root, we need it to be to the 4th power. So we need 6 cubed more. Okay, and we need to distribute into the numerator. So in the numerator, we have negative 5 times this radical, so 6 cubed is 216. And then multiplying here, we have a 5 on the outside. And then the 4th root of 5 times 6 cubed. Okay, so 5 times 216 is 1080. Okay, let's see what happens in the denominator. We've got a 3 on the outside, and then 6 times 6 cubed is 6 to the 4th. So these cancel, or these match, so I get to take the 6 outside to join the 3. 6 times 3 is 18. So that's my denominator, and let me copy down the numerator. Okay, so 26. I need to get the denominator to make everything cubed. So let me rewrite the 15. Let me just copy down the whole thing first. Okay, so I've got a 3 on the outside, then the cube root. 15 can be rewritten as 3 times 5. Okay, so I need everything in this radicand to be something cubed. The x is already there, but the 3, the 5, and the 9 are not. Okay, so I need, these are all to the first power. So to make them cubed, I need 2 extra 3s. I need 2 extra 5s. And I need 2 extra 9s. 2 extra y's. Okay, so let's see what this turns into. So the denominator, we still got the 3 on the outside. So now the 3 is cubed, the 5 is cubed, and the x was already cubed, and now the y is cubed. Okay, so let me just simplify the denominator first. So the 3 goes outside to join the 3, that's 9. The 5 goes outside, 5 times 3 is 45. The x goes outside, and the y goes outside. Okay, so we've got our denominator. Let's see what happens in the numerator. Okay, so we need to distribute. So what is 3 squared times 5 squared? That's 225. So multiplying this times this first. So I've got a negative 2x as the coefficient, and then cube root of that. And then now I need to multiply this times this portion of the numerator. Okay, so these are both inside the radical, so we multiply the radicands. Okay, so we got a negative, we got the 3 squared. So 5 times 5 squared is now 5 cubed. Okay, so this x to the 4th, I'm going to split up into x cubed times x to the 1st. And then I'm going to keep this y cubed and y squared separated. Okay, so I probably could have done some reducing earlier, but I'll just have to do it now instead. Okay, so this one, I can't make anything cubed out of these, so I'll keep this portion of the numerator for now. Okay, over here, so I can take the negative out, so now it's a minus. I can take the 5 out. I can take an x out, and I can take a y out. Okay, so what's left over? I've still got the 3 squared, which is 9. I still have an x, and I still have a y squared. Okay, so let me copy the denominator from above. Okay, so now I check, is there anything in all the coefficients that is in common? And yes, they all have an x, which I can divide away. Okay, so what's left over is -2 cube root of 225y squared minus 5y cube root of 9xy squared all over 45y.